person forgot and they just put A for everything. Thank goodness the person updated it and they fixed it and they made an updated version where they now have different letters and numbers and in some cases symbols because they ran out. So you get to tell me, okay, which letter now specifically or number or symbols that you want. We're gonna say gravity applies this time around, so like you can't pick A because your Connect before would not just hover at the top of the Connect 4. Has everyone played Connect 4 before?
It's Connect 4?
This is basically Connect 4.
Alright.
Okay, yeah, so Connect 4, yeah, so basically you want to get 4 in a row. So it can be across, it can be up and down, it can be diagonal. Sometimes people play away where you get a square, it counts. We're not doing that. So it has to be in a line. Wait, Richard? Yes.
We get time to both get game because we're probably not the page.
I'm gonna say if you get a tie, no. I did have one year where I gave them a piece of candy because they filled up the entire board without anyone winning.
How?
And it's skill. That's probably the reason why I was like, okay, just because it looks cool, I'll let you have it. But no, for right now, nope. If there's no winner, then there's no winner. There's no candy.
So gravity applies. So if I choose A, it goes down to 5.
Yeah, it goes all the way. So just say 5 because obviously gravity would pull it all.
Why did they
down.
put the percentage symbol when they could have just put a 0?
They just chose the percentage. I didn't make it. Alright, we'll start with Ethan. Alright, Ethan, you should know it by this point, but what is the equation if you're going from Fahrenheit to Celsius? So it's C equals what?
9/5. Fahrenheit temperature.
I forget y'all are in chemistry. Physical science is doing the exact same thing, but they don't have the temperature symbol with it. Okay.
For Fahrenheit?
You're going from, I said Celsius to Fahrenheit. Excuse me. Okay.
Plus 32.
Perfect. Alright, pick your spot.
5.
That works. Alright, what color you want?
Blue.
Alright, Chris, what is the other one then if I'm going from Fahrenheit to Celsius?
5/9 parentheses TF minus 32.
Good job. That is it. That's really messy 32, I'm sorry.
Hit me with that Y.
You want, what color you want?
Yeah.
Okay. Ethan, back to you. Alright, what is the temperature if you're going, temperature comparison, if you're going from Kelvin, well, we'll just say Celsius to Kelvin. So, you're finding Kelvin.
We're finding Kelvin.
You're finding Kelvin, going from Celsius to Kelvin. So, you should have the temperature in Celsius. It's shot, basically.
Minus 273.15.
Final answer. Check it.
We're going to Kelvin to Celsius.
We're going from Celsius to Kelvin. You're finding Kelvin.
Plus.
Final answer.
Yes.
Yes, you are correct. That yes, you add it. Alright. Pick your spot.
8.
8. Oh,
I said he didn't pick 8. He's way down there.
Yeah,
it
you're
was.
right.
I was like, is there any?
Alright. What is the coldest possible temperature?
0 Kelvin.
Good job. What's the other name for it? 8. 8. Alright, I'll let you have it because you said 0 Kelvin, but absolute 0. Absolute 0. Okay.
Let me go for 6.
Alright, let's see. We're going to kind of skip over 6 because I think you've got it for right now. Alright, what is the energy of motion?
Kinetic energy.
Good job.
Second.
Alright, what is an indirect measurement of the particle's average kinetic energy? Indirect measurement. T. T.
Say it again?
An indirect measurement of the particle's average kinetic energy. So, what do we do to take your average internal energy? Temperature.
Let me go for
liquid, gas, or plasma has the least kinetic energy?
Liquid? No. Which one has the least kinetic energy?
Which one has the least amount of energy? Solid, liquid, gas, or plasma?
Yeah, that's a hard one. I'd say solid.
Solid is correct. I'm not trying to help anybody, so I'm gonna keep my mouth off it.
I guess solid does kind of make sense because solid can't move on its own. The water can, gas can, plasma can, in a way.
If
Not by themselves.
yeah,
but-
I know what you're thinking of, but yes, you're right that that's the reason why we assume the solid stays put is because it doesn't have a lot of energy.
I guess a lot of
One.
science- I guess a lot of science is common sense, isn't it?
Well, for right now, a lot of it, as we get more advanced into like the theoretical side of it, it's gonna get a little bit harder. But yes, right now it's keeping it basic. All right, which one has the most kinetic energy? Solid, liquid, gas, or plasma? Plasma. I also said them in order, so that helps.
I'm gonna go for 2.
Okay, now I got it. Alright, what state of matter is the most abundant matter if you're talking about the entire universe? Solid, liquid, gas, or plasma?
Wait, say it again?
Solid, liquid, gas, or plasma? Which one is the most abundant state of matter in the universe?
The most abundant?
Most abundant, like we have the
Plasma.
most plasma. Just think about all the stars.
9.
I forgot how to wait for a second. Alright, what, if you're going from a solid to a liquid, what do you call that transition point in between them?
Solid to a liquid.
Solid to a liquid.
Start with them.
Yep.
Melting point.
Melting point. Like I said, it's basic right now.
Let me go to percent.
Percent sign. Alright, if you're going from a liquid to a gas, what's that transition point in between them? Jamie can't see me.
We're going from a liquid to a gas?
We're going from liquid to a gas.
Boiling.
Boiling point.
3.
Let's see. What is the smallest particles that are still a whole substance? So, what do you call it to where you chop down gold until it's smaller and smaller to where it's still gold? Or you chop down silver until it's smaller and smaller until it's still silver?
Start with it.
Yes, there's an A. Atom.
Let me go with you.
You are right. Alright, what do you call substances that are pure substances? You find these out in nature. They can't exist as just atoms by themselves. I think how I can word it and not have it be confusing. What do you call these? There's 118 of these. That helps you out.
Say it one more time.
Alright, what do you call substances that can be broken down smaller and smaller into a pure what?
Element?
Yep.
T.
Alright. What is just a group of 2 or more atoms that are just linked together? A molecule.
B.
Alright, what do you call 2 or more different atoms that are hooked together? Talk about this very quickly at the end of class.
Say it again?
2 or more
Molecule.
different. Okay, molecule is just 2 atoms hooked together. What if it's 2 or more different atoms hooked together?
Start with
C.
C?
C.
C?
C.
Is that what that?
What do you call it if it's 2 or more different atoms? So like a water molecule has hydrogen and oxygen hooked together. So it's 2 different atoms hooked together. So it is a molecule, but there's a more specific type whenever we mean it's 2 or more different atoms hooked together. Alright, Chris?
What's the second one?
Nope.
I don't know.
Alright, compound, write it down. I think I talked about it super quickly at the end of class and I'm running out of time. So compound, we'll talk more about it today. Alright, you can use the periodic table, and then if you want to use the chart in your book for no, you can use the periodic table, but that's not going to help you a whole lot, but you need to start knowing these. So, Ethan, back to you. What is this one?
That is iron.
Nope.
Argon?
Nope. Alright, there's one reason why I tell you, if you want to start studying these, if you want to use periodic table, This one is silver.
That's what it was. I knew
Silver.
it was somewhere around there.
Alright, what is this one?
I'm just starting with one of these, so.
Okay, I'm gonna let you get out your bets in a second, so that way you can cheat and cheat if you need to in a minute. We'll do it at
HG
time.
is,
Nitrogen.
Nope. Alright, get out your books, turn over to
No,
page 19.
I wanna do the books.
I
You
don't
wanna
wanna
do
do
it?
the books.
You don't wanna do it? We're gonna be here forever.
That's fine.
Okay.
lithium.
Good job.
S.
I'm gonna make 2 stacks. I remember which ones I got right, which ones I got wrong. Alright.
What does it start with? Does it start with an N?
You gotta memorize them.
Huh, what?
Couple seconds, we gotta go.
What?
N-E?
Yep, well, I mean, in E. I can't tell you what they start with because sometimes they help and sometimes they don't. Like, sometimes they start with these letters and sometimes they don't, but you just gotta memorize them.
Nitrogen.
Nope.
Is it neon?
Neon is correct.
M. I win.
You do. Alright, so we'll do this one more time super quickly because I have a whole stack that we gotta get through, or at least
Are
partly.
the
I'll
only
probably.
ones we're supposed to memorize?
This is. Like, there's about
There's the
40
bold
something.
ones.
That much
in your
that we have to memorize?
in your bold table on page 19, there's about 42 if I remember correctly.
How'd you make
How'd you have to
flashcards?
memorize?
What, that you have to memorize, yes.
Because there's only like 16 that were bold.
There's way more than 60. You need to go back and double check that list.
Okay.
It's like 40 something if I remember correctly. They count, it's 44 because I wrote it down last time.
What page?
It's on page 19. Alright, let's do this one more time so that we can get through at least part of them. I'm going to divide them up, so I'm going to keep the ones we've already done off to the side so it helps you start memorizing them. But this is just going to be hard for right now. Alright, so Ethan, what is this one?
Oh, what?
Alright, Chris, what's this one?
Copper.
Nope,
Oh wait, no, I'm dumb.
it's okay, guess again.
Is it, chlorine?
Nope, cobalt.
Cobalt.
Cobalt. Alright,
Cobalt.
cobalt. CO. If you try CO, it'll help you remember later. Alright, what's this one? Na. I wrote this one on the board yesterday. Thinking about table salts, if that helps you.
34.
Okay, so it's just the Na, so which one is it?
Sodium.
Sodium.
Not available.
Alright, what is this one?
Percent.
Oh, you got it right. Pick a spot.
Percent.
You still want me to glue?
Next to that now.
What color was
The
that?
second color.
Oh,
After red. That
like
one.
funky orange?
Yeah, so he can be red. Unless he
My
picks the
eyes
last
hurt.
one.
Nitrogen?
Nope.
What? That's not nitrogen.
Nope.
What is it?
It's a guess.
He already guessed, he guessed nitrogen.
Oh, he said it's not nitrogen. Like as a question because you guessed it.
I don't know.
Nickel.
That's what I thought.
Okay. Let's see. I have 7. We'll do 3 more so you can start doing these. Okay. Chlorine is correct.
9.
Alright, you want to be right again?
Yeah.
Okay.
Aluminum.
That's aluminum. So some of these are easy.
Let's just go 3.
Alright, this one
Gold.
is correct.
4.
Alright.
Krypton.
Krypton is correct.
8.
Funky color.
CR.
CR. I don't know if you can see it. Or
Carbon.
is it? Not carbon.
It's right there. I don't know.
Alright, chromium.
That's what it was.
Chromium. Alright, we'll do 3 more and then I'll start mixing these up again. Alright. Alright. Arsenic. Like the poison. Arsenic. Alright, this should hopefully be an easier one. Hopefully. If not, it's okay.
Ferrite.
What?
Ferrite.
I don't think that's another one. Alright.
It is.
Boring.
Fluorine. So fluorine for it. So it's making up F. Fluorine. Where's it at in the periodic table then?
2.
I don't know where it is, I just know that. I just know Ferrite is one.
It might be an ore. So I don't know if I've heard of that one
2.
before. So just be careful what we got. Fluorine is one you want to know. It sounds kind of like an ion version of it. Alright,
Two.
let's do this. Oh, thank you. Alright, last one. So you got flooring. It's the last one for you. For right now, and then I'll remix up these cars.
Where is, that's something else.
That's in the cell. You're thinking of biology. Okay, it's been a while.
I know. Rival or something? Radium or something?
Okay, you're thinking of radon, but that's a different one. This is rubidium. So
That's what I was
rubidium.
thinking, right?
Alright, we're just gonna do the same cards that I just did a minute ago. So this is not all of them. Do not think this is all of them. I'm just doing it so that way it's a little bit easier for right now. Alright, so based off the ones you just wrote down, hopefully I'm starting tonight or tomorrow night because there is a bunch of them. Alright, so what is this one then? Neon, good. Is that V? So you're red. Alright, Ethan.
That is. What's that? AG. Silver?
Silver.
That's what I
Good job.
I thought AR was over, sorry.
W.
Alright.
This thing is super Krypton.
Krypton. Yep, that's the home
Kryptonite.
planet. Superman. Okay, well, Krypton is the infant element, but yes, Kryptonite is whenever they refer to it in things. So be careful. So Krypton. If it helps you remember, Superman's
Were
home
they
planet.
referring to the
fine.
same thing when they made Kryptonite?
Whenever they're talking about like I think like a section of it, like oh it's Kryptonite, here's a section, but it's from the planet Krypton. The element is Krypton, not Kryptonite. So just be careful. Krypton is what you want to write down.
I don't want to say Kryptonite. No.
Okay. Pick your
7.
Okay. Alright. I don't know if y'all can see this. I'm
Oh,
sorry.
AU?
Yep.
That is a low, is that the one with the salt?
Nope.
No.
I guess.
Yeah,
AU.
second. Let him guess first.
Arsenic?
Nope. Gold.
Gold is AU? I thought
Gold
it was AG.
AG is silver.
Let me go for
Gold is easy.
1.
There. Alright. So back over to Ethan.
Aluminum?
That is aluminum.
Q. Let's see what you do.
Alright.
Nickel.
Nickel.
Okay.
Alright, Ethan. Slide it
Lithium?
that way they can see.
Lithium?
Yep.
U.
Alright.
Is it for me?
Yeah. I'm trying to do it so they can see it too. I want them to be able to see the screen. Not chromium.
Cobalt.
Cobalt.
I have that in my notes too.
Sorry. Make a note to just go back and just review it since it's getting you stiff.
Oh.
Okay, let's
Oh,
go.
That's wrong color.
Oh. Chlorine.
We go
In A.
An A.
In A.
No.
Alright, Chris.
sodium.
Sodium.
That's what it was.
J.
Alright.
I had to get this one.
Yeah, you better.
HD
Yeah.
is.
That's the next one. That's the next one I grabbed.
I don't know. HD. Let's go.
We can give a minute.
No. I didn't do it to you, so I gotta be fair. I can't just help out you think you're about to win.
Silver. No.
Silver?
No.
Okay.
I don't know what it is.
Oh, okay. Okay, you don't know, Chris? Alright, Mercury.
That's a
HG,
good one.
Mercury.
We didn't do
It's
that
based off its old name, so just make a note for that.
We didn't, wait, HG was his old name?
Its old name, I forget what the old name was, it's for Latin, but yeah.
When? Like long.
Oh, yeah, like way, but like ancient times, whenever they were doing alchemy and witchcraft back in the medieval time period, they came up with special names for all
Is it
of
my
them.
turn or his turn?
Technically it's history because no one got it. Alright, but you still got a hard one, so that's the next one.
You know that one? You do?
Alright, just guess, Ethan.
Harvey. Oh, this is the rabbinic, but not really also.
That's close.
Reddit,
Why do you have that? What?
Reddit or something like that.
Redditic?
No, like it's near Reddit or something like that.
If you close your, I have to let you have it.
I haven't read my notes, so I don't know.
Well, I mean, you wrote your notes, Ethan could have if you wanted to.
Verbatim.
Rubidium is correct. Alright.
I.
Alright. Really?
Yes.
Okay.
Oh, he's gonna win either way.
Alright.
He has two options
I
anyway.
know, well, do your best. Maybe he'll.
Glory.
Yeah. Pick whichever one you want to do.
Choose your
Actually, oh.
What did he choose?
Wait.
Never mind.
What did he choose?
I need to choose it. Pick spot.
It's not that hard. I only have one
I get
option to
that.
win. I only have one option to win.
Rookie?
Mm-hmm.
Oh yeah. Okay. D. But
Alright, these are the last two then.
Arson.
Good job.
What? Yes.
X.
Oh.
Alright, last one then.
Oh, I know what to do. CR Chromium.
Alright.
We have to do. We have the game's number. We're close.
No, I'm on the cards. You gotta go.
E.
There's
Alright.
some old questions then. Oh, it's the wrong color.
Oh.
So technically, like, no one wins this.
Yeah.
So
Game over.
can we go through like some of the terms that so there's only.
No, we're not gonna waste time just because you chose to not
Just trying to
win.
trick me.
Alright, let's turn over in your
Okay,
textbook to
okay.
page number 19 is where we technically left off. So
Okay.
19, you make a note for it. So don't forget your candy if you won. So we played 2 rounds, so someone won the first one. So don't forget your candy, please. Alright,
Remember that. I
so
was giving it mine anyways.
okay, that's fine. So, page number 19, start learning that table. Yeah, I counted them last year and I wrote 44 down at the bottom for it. Double check the count because I wrote 44 and I counted them a bunch. So just be careful for it. It means you want to learn an extra one, cool. Just make sure that you are knowing them for it. Now, we call these symbols for it. We call these the atomic symbols. These are the symbols that we use to help identify elements because writing out the element's name over and over and over again gets cumbersome. So scientists wanted to come up with kind of like a shortcut method or like an abbreviation for it.
I got
But
45.
they wanted to make it a little bit easier. What?
I got 45.
No, I'm sorry, kind of good. Alright, so molecules, these are groups of 2 or more atoms that are linked together by chemical bonds to form a distinct unit. So those are 2 different atoms put together. We talked about this with water very briefly yesterday, and I think that was about as far as we got for it. So make sure that you know molecules, a compound is 2 or more atoms that are different that are linked together. So like water specifically, those are 2 or more different atoms hooked up together. And that's why we consider it a molecule, but then more specifically a compound as well. Now sometimes you can have a molecule like water likes to exist by itself, like oxygen in the air that you're breathing right now. This does not just exist as a single oxygen atom, it exists as a diatomic atom, to where there are 2 of them always hooked up together. That's because of how oxygen likes to bond. We'll talk more about the chemical bonds later on, so don't worry about it right this second, but that's the reason why for it. There are some elements that like to exist diatomically. So your book tells you, you should memorize which elements exist as diatomic molecules, and your book's not kidding. You should memorize the top of page 2.2, all of them. There's only about 7 of them, and then you want to memorize the bold ones in table 2.3. So you want to memorize the bold terms and page 19 and the table 2.3, and then at the top of the page, table 2.2. Now, for this one, there's an easy trick for it. Hydrogen wants to exist diatomically or with a partner at all times. So hydrogen, I know I shifted away for a second. Let me grab my recording so I can shift over.
Wait, what?
Okay, you can't see it. I'm sorry. Look in your book, Jimmy. Alright, top of page 19, table 2.2.
What?
Very top.
Memorize that?
Yes.
The whole time?
Yes.
I think you can memorize.
Yes. Wait, what?
You can memorize them anyways.
Well, no, you memorize that these exist as diatomic. There's always two of them. Don't just memorize oxygen. Oh, yes, you need to know that. But you also need to memorize oxygen likes to exist with a buddy at all times. You do not find oxygen by itself chilling out in nature. Oxygen does not do this. Oxygen always goes, buddy, I need a buddy.
When the world implode.
What?
When the world implode. When the world kind of implode because fire and oxygen would just.
Okay, well, you have oxygen in the air. But oxygen does not like being by itself. It has to do with the number of valence electrons or electrons that it has, so don't worry about why it works the way it is right now. But it wants to always have a buddy. So just note that it always has a buddy constantly. It does not like to exist by itself. Wait, what?
There's the two at the one.
Yep, so that's what I'm talking about. There's a two for this one. You do not find this out in nature. It never exists by itself.
Bromine too.
Sorry, one more time?
BR2, like, for the bromine.
Oh, yeah, that's what, so if you see like the name, and then you see like the formula, that's how they all have twos after them, because they're saying, I want to exist as a buddy. You never find them out in nature just by themselves. They always have to have a buddy. It has to do with how they're bonded. Again, talk about it later, so don't worry about it right this second. Alright, Jamie and Quentin, you can't see my table. The camera's too far over. I'm sorry, if I remember to shift it for tomorrow. But just look in your book, or look in I'll look in the back table so that you can look at a periodic table as well. Now you'll notice that hydrogen on the periodic table, this over here, now this one always wants a buddy. Over here, it makes kind of like a funky L shape. So if you just want to remember, it makes this L pattern. These are the ones that exist diatomically. Nitrogen, oxygen, fluorine, bromine, and then iodine. Or these are the 7 over here, and then 8 with hydrogen that exists always with the buddy. So if that helps you, I'm sure remember, okay, it's the funky L shape, and then hydrogen. Cool. Whatever helps you to remember which ones work. Or you could just memorize it's hydrogen, oxygen, nitrogen, fluorine, bromine, iodine. You can also memorize it just off the names as well. Either way works. Last year students like to memorize it based on it's in this L pattern. If that helps you, use it. Use whatever can help you to remember that those are the ones that like to exist diatomically. They always exist as a buddy. Alright, any questions about that? Alright, atomic symbols. These are the symbols that scientists use to kind of give them abbreviations. Already talked about that. Flip over to the next page. Alright, your book points out some of them come from their old names. So tungsten, it has a W because it's from its old German name, Wolfram. So your book should tell you there's older names for them or there's old phrases for it. So because of that, scientists have decided we need to have a better way to name them. And in some cases, back in ancient medieval time periods, they would have to come up with kind of like each scientist would come up with his own basically recipe for how to combine the different elements. Now, it was kind of sketchy in that era. Your book has on the figure on the middle, page 20, ancient and medieval chemical symbols. We associate this in a lot of cases with witchcraft, with games today. Okay, now these symbols themselves aren't bad, but the scientists weren't really sure what they were doing at the time period. They knew that something's happened whenever they mix these different substances together. It wasn't really witchcraft in most cases. Some of them, depending on what they were trying to do, yes. But in most cases, just mixing elements is not dangerous in the idea of like the occult. But it was the idea of they were just mixing stuff together and trying to make a new substance. Because the Catholic Church didn't like it, the Catholic Church in a lot of cases condemned it, and that's when we associate some of these symbols with witchcraft. Is it about the symbols or is it about witchcraft? What?
Yeah.
Which part?
Yeah.
Like, no, is it about chemicals or is it about witchcraft? Because I don't have time to get into the occult. If it's a chemistry question, okay. But if it's about the occult, I can't talk about it right now because I don't have time to get into it.
By witchcraft, do you mean like would they do like human experiments with these different elements?
If you were a bad scientist or alchemist is what the term typically was for them back then.
And that's obviously those illegal, right?
Yes. Catholic Church condemned it during the medieval time. It wasn't so biblical. But again, so the lucky is because the Catholic Church didn't like the idea of you creating, because God can only create. Now, they're not fully creating. They're taking two substances, mixing them together and have a chemical reaction. But that was a lot of cases condemned by the Catholic Church, so they would call you a wizard or a witch in a lot of cases, and if they caught you doing it, you're in trouble. So again, it was superstition time period. They didn't really, but they were just scientists just experimenting in a lot of cases for it. So, your book points out there are 118 elements identified so far. 88 occurred naturally, while the others we can make in a scientific laboratory. If you notice that these down here now have official names, if you look in the back of your book, because your chemistry book has not been updated, they still have their temporary names. So if you want to make a note of their real names now, you can as well for it. But there are 118 elements. So 88 occur naturally, 2 significant amounts. Most of the elements are the same, like repeating elements over and over and over again. Like oxygen is the most abundant element by mass if you're talking about the Earth's crust. Now, if you're talking about the entire Earth, does anyone know what element we think is the most abundant? Carbon? Nope.
Cool.
Okay, coal is carbon, but no. Alright, if you're talking about the entire Earth, because of the what?
Steel,
Not steel. Okay. Ooh, close.
Potassium.
Okay, what makes steel?
iron.
Iron. So they say
Freaking
because
iron.
of the molten core of the
Iron.
Earth, they think in the magma, they think that it's probably iron. So that's what found. They say, okay, if you're talking about the entire Earth, iron is the most abundant element. If you're talking about the Earth's crust, that outside layer, then oxygen is the most abundant element. Does anyone know why oxygen is the most abundant element?
And oxygen in the and
Yep.
also in the extra
Okay, but yeah, but what exists on the Earth's crust that has oxygen in it? What?
trees photosynthesis.
Yep. Oxygen, carbon dioxide. Alright, anything else? What? Yep, so we have it in our body plus the carbon dioxide and oxygen. Anything else at the Earth's surface? What?
Grass.
Okay, grass.
Animals.
Animals. I'm thinking of a particular
Wood.
liquid that you have a whole bunch of on the Earth's surface.
What?
Water. So that's the
Where?
reason why. So between all the water, all the air, carbon dioxide, oxygen is the most abundant at the Earth's crust, that top layer. But once you start digging down deeper because of the magma, we think it's probably iron at that point. Alright, so just making up for it. Do you have a question?
So we'll never know.
Yeah, probably not.
We
but it's one of
might.
those. It's one of those. Best guess seems like it's iron. Alright, now keep in mind though that the most abundant element, if you're talking about the entire universe, is hydrogen. Now, if we're talking about the entire universe, what are we factoring into at that point?
Space.
Space and
Planets, stars.
stars. So that was the main thing. So remember, because we think that stars are made up of the hydrogen reactions, and with at that point nuclear fusion and fission, we think that most stars are made with the same composition as our star, the sun. And so because of that, since our sun has predominantly hydrogen, we think okay, it's safe to assume all the others also have a good chunk of hydrogen as well. Some of them have different compositions, that's why they have different colors slightly in some cases around them. But it's the idea of, okay, hydrogen is probably the most abundant, so it's safe to assume, since our star is predominantly made up of hydrogen, all the stars are predominantly made up of hydrogen. So hydrogen, we think, is also the most abundant element in the universe. The same way as like plasma is the most abundant state of matter, hydrogen is the most abundant element. Do you have a quick question?
Suppose they're always exploding nukes with nuclear fission, or is it just
Okay,
massive nuke?
Okay, fusion and fission are two different ones. So fission is whenever you have one element split apart into two, that's a nuke. The stars are actually doing fusion. We're taking two substances and putting them together. It releases way more energy actually.
So why don't we so if you're trying to make a nuclear bomb, why don't we just do that instead?
Because we can't. We're struggling with doing it properly
We
without.
tried.
Yep.
And
We talk about later on. I think it's like the last chapter in chemistry. It's very difficult for us to be able to get it and then control it.
So we try to go with that.
You have to heat it to a very high temperature and pressure, so having it that hot under that pressure is very difficult to manage on Earth and still be able to control it. Because no one wants to do it and then die, because that defeats the purpose. So it's one of those, we're trying to, do it and control it at the same time, and it's very, 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 very difficult. So we're trying, so ideally that would be a good solution to energy, but it's one of those, we just can't duplicate it very well yet. But that's the reason why the sun gives off so much energy, is it's constantly doing that over and over and over and over and over again. Okay.
So I've heard things about eventually the sun will go out and we'll have this obviously won't die, but it'll go out. Is that because it runs out of hydrogen?
There is a it's combining them. Yeah, it's one of those. Okay, you're asking me, will it ever happen or could it happen?
It's gonna happen. It's not could it happen, it's when it will happen.
Okay, well, when will it happen?
Within years. But I'm saying, is it true, you think?
Well, I mean, like God said that He'll destroy the earth with fire. Maybe He'll use it with the sun. So the sun will be here at least till that point, and we have 1,007 years if Christ came back today, because you have the 1,000-year reign and then the 7-year tribulation period. So the sun will at least be around for 1,007 years. Will the sun go out before Christ come back? No, because the Bible says that the earth will still be here when Christ comes back, and you're gonna have seasons.
The earth will.
Yeah, well, the seasons will still be here as well. The Bible says day and night, winter and summer will not cease till Christ's return. So again, the sun will at least be here for that time period up until that point for it. Now again, God might decide he comes back today, so the sun will die potentially in 1,007 years, because that's whenever it'll come to point. Or God may decide he wants to wait another 2,000 years. God will probably not wait billions of years. It seems like it's coming pretty quick. Maybe another 1,000 years if he sends revival. But again, it probably won't last the billions of years because it seems like God wants to wrap it up before that point. Okay, we gotta keep going though. Good questions. Just remind me after class. We gotta keep going. Alright, so compounds. So just make a note for compounds. These are two different elements hooked together. I've already talked about this a bunch. So molecules are both of these types. You can have a molecule where you have two different atoms. Well, excuse me, two of the same atoms hooked together, like a diatomic atom. Or more specifically, you can have a molecule where two more different atoms hooked together. This specifically is a compound. I've already talked about this term. Just make a note for it. That a compound is composed of two different atoms hooked together. You might point out a substance such as water can be decomposed by electrical means into simpler substances. You can actually electrocute water and make oxygen and hydrogen come off from it. Don't try that because it's dangerous. You'll probably electrocute yourself first. But they can actually run a current through water and get the oxygen and get the water molecule to break apart into the hydrogen and then the oxygen. The oxygen is unstable because it doesn't like being by itself, so it'll find other water molecules that have been broken apart as well and bond up to them. So that's part of the reason as to how come scientists figured out that water is not a pure element. They used to think water was an element, like you could find it on the periodic table. They know today, nope, it's made up of two smaller atoms hooked up together to make this one compound for it. So your book gives you the official definition of a formula. I've been writing them and you probably already know it, but just make a note, a formula is a grouping of symbols that tell what type of atoms compose the compound and the number of each type of atom in one molecule of the compound. So like for water, H2O, there's two hydrogen atoms to one oxygen molecule. Diatomic oxygen, there are two oxygens here. For this one, you have these two substances. Alright, so this one would be CO2 or carbon dioxide. Where do we get carbon dioxide from? Anyone know? Raise your hand. Raise your hand. Raise your hand, Ethan. Okay, Ethan, what? From you. You just breathed out carbon dioxide. No, you normally do it all the time. Now, carbon monoxide or CO, where do we get that from? Anyone know?
Carbon monoxide?
Yeah.
It's a gas that goes, I'm assuming from fires, right?
I mean, I guess you could. There's a way that this is made.
Gas?
Yeah, well, gasoline, yeah. So your car with combustion automatically makes carbon. Automatically makes carbon monoxide. What's your question? Yes. But is it something to where it's more of you're thinking more of methane though specifically. But this is whenever you're having carbon monoxide or combustion. That's whenever your car reacts with the gasoline to make. This is one reason why you don't sit in your car in a closed garage for too long. You'll start breathing it, and then you may pass out and die. So that's the reason why you don't do that. Alright, so pure substances and mixtures. Finally talking about this slide now. So a pure substance is a substance that has definite composition throughout it. A pure substance could be a compound or it could be an element. An element is obviously pure. Like if you were to have a gold bar of pure gold, you expect to have all gold throughout it and it'll be worth a lot of money. But that's the idea of it is a pure substance. It's made up of just gold or just carbon. Like for example, does anyone know what is a substance that is made up of just carbon? So raise your hand. Right?
Carbon.
Okay, yes, if I get a bar of carbon. But what else can I find in nature that is also made up of just carbon? And only carbon. Not just rocks. It's like a specific type of rock.
Gold.
It's carbon in gold.
I'm just kidding.
Yeah. Okay, fine. Sorry, person thing.
Coal.
Cold one. Alright, you think of it. Alright, do you know the other one?
Uh,
You get this type of rock for the special lady in your life eventually.
diamond.
Diamonds!
Diamonds!
So, diamonds and coal are both made up of pure carbon. It's just how they're made determines how the carbon hooks up together, so that's what determines their properties. But those are examples of a pure element substance. Compounds, we've already talked about this. Now a compound is made up of two different elements, but it'll be those two different elements hooked up together and they're chemically combined over and over and over again. Like if you were to have water and pure water, it's just the same composition, H2O, over and over and over again. You should not have H2O and sodium chloride mixed together. That is not a compound pure substance at that point. Anyone know what sodium chloride is?
Sodium chloride is.
Yep, the table salt. How many of you have had to gargle salt water before? Yeah, you've never had to gargle salt water? Okay, typically you do it like if you have something worked on with your teeth, like if you get teeth pulled out, or if you get your tonsils pulled out, or if you have a sore throat, your mom or the dentist might tell you to gargle with salt water. It's not fun. It burns and it tastes gross.
My mom is Caucasian, so I don't know what salt tastes like.
Okay, make sure that you are not wasting my time. You understand? Okay, so in some kinds you can have a pure substance. Now, not with fixed composition, but it can be homogeneous. Go ahead and mark that term in your book of page 1. Homogeneous or homogeneous. Sometimes you hear two different terms for the same thing. They are very, 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 very similar to ideas. Technically, they have a slightly different definition, but homogeneous or homogeneous, I'll take either one for it. Most people, whenever they say it, they just mean a slightly different pronunciation for it. So if you know homogeneous or homogeneous for it, this is whenever they have the basically same composition all throughout, but they're not chemically hooked up together. So if I were to mix sugar into water, would I be able, and if I were to do it properly, would I see the sugar in the water?
No, you would. Well,
Yeah,
no.
if you do it properly. Now, if I were to just take the grain and just dump it in and not stir it or anything, you would see it at the clump at the bottom. But if I were to heat it up and then stir it up to where all of it dissolves, I wouldn't be able to see it at that point. So it would look typically kind of like cloudy water, depends on how much sugar you added into it, but it would all look basically the same all throughout that. Now, it's not a fixed composition, so it's not considered a pure substance, but it is considered homogeneous or homogeneous because it all looks the same. Now, if I have salt water and I need to get fresh water from it, what can I do to get the salt out of the water? Filter it. So that's one way to tell a mixture or a substance that is combined, that is a physical mixture of two substances from a pure substance, a fixed composition, is you can take a physical substance and separate it by physical means. You can either filter it with the salt water, or you can use evaporation, because if you were to stick a pan of salt water out on a beach somewhere, the water would evaporate and leave the salt behind. So they can be separated by a physical method. So to make a note, a substance that consists of two or more pure substances that are physically mixed but not chemically combined is a mixture. Now, sometimes students they get confused because both of these are homogeneous. They both look the same. If you look at your eyeballs, they look the same throughout. One of them, though, is chemically combined to where they are locked together. The other one is just two different substances mixed up together, and you can re-separate them back out. All right, anyone have any questions about those two ideas before we move on? All right, a heterogeneous mixture, or heterogeneous, again, two different pronunciations for basically the same thing. A heterogeneous mixture, this is whenever they are a mixture of pure substances, but they are incompletely mixed. You can see with your eyeballs that they are not the same thing throughout. Like a granola bar, you can see there's different junk in a granola bar, whether it's raisins, almonds, oatmeal. You can see, okay, this is not the same thing. It's all mixed up together. So, homogeneous. Another name for them is a solution. As a side note, your book gives you that definition a little bit later on. Let's see. Heterogeneous, this is whenever you can clearly see these are two different substances and you can see that they're mixed together. Like if I were to mix, like for example, red and blue marbles together in a jar, could you see that it was two different substances? Chris? Yes, so would that be an example of heterogeneous or homogeneous mixture? If you can see two different substances. Heterogeneous, because you can see with your eyeballs, typically, they're two different colors. Now, what if I were to mix red and blue paint together and stir them up? Would I be able to tell at that point that it was red and blue paint mixed together? If it were to stir it up properly. What? Alright, what happens if you mix red and blue paint together? What do you get?
Green.
Red and blue.
Purple?
Purple. So if I get purple paint, could I see there's the red paint, there's the blue paint in the paint throughout? Or is it all blended all together at that point? It's all blended. So we would call that one a homogeneous mixture. It's all blended together at that point. Alright, some cases you get a phase, so make another homogeneous part of a system that is in contact with, but is physically distinct from other parts of the system. I left my salad dressing downstairs by accident. Alright, how many of you have seen Greek or the nice Caesar salad dressing before? Alright, what?
Yum, yum.
Alright, now, what are you supposed to do with the Greek dressing or the salad dressing or Caesar salad dressing before you just dump it on your salad? What are you supposed to do to the bottle first off? Anyone know? You're supposed to shake it up. Why?
Those, getting the oils and stuff separated too.
Yeah, what happens if you don't mix it up?
And it squirts out like a bottle of unshaken up, it's just pure water.
Yeah, it's basically that top layer is typically the oil. So if you dump it out, you just dumped oil on your salad, basically. You typically don't want just oil on your salad. It's kind of gross, typically. Most people want them to shake it up first. So that way, so you get all the mixture of all of your spices and their seasonings on the inside, all mixed up together on the inside for it. So, phases, that would be like if you look at a bottle of, this is a very poorly drawn bottle of Caesar salad dressing. Alright, so you would see that there's typically the spices and stuff down at the bottom. You might have some other liquid higher up, and then that top part is typically that oil section at the top. You might get a layer of water even on the inside for it. So you get those different sections of your salad dressing, either in Greek or in Caesar salad. The nice ones, they have those different phases, those separate out. So just make a note that a phase is a homogeneous part of a system that is in contact with, but physically distinct from other parts of the system. The oil is all together, the water is all together, the rest of the spices are all together, but they're all separated from each other. So just make a note of what a phase is. Rebecca is showing you a picture of water and oil as well. Alright, and I have a question about this. Alright, next page really quick. John Dalton and the atomic theory. So John Dalton, he proposed a more extensive model trying to describe what an atom is. The early Greeks came up with some basic definitions. Your book gives you one of the early Greeks. You don't have to know his name, Democritus, so you don't have to know him though. But he said that okay, that there are two different types of atoms. Now sometimes you have substances, sometimes why they slide together, and why sometimes they stick together. He thought that each substance was made of its own kind of type of atom, which he was right in the idea that some atoms like to stick together better than others, but there's reasons why we'll talk about later on for it. John Dalton, he proposed the 5 parts of his atomic theory. We're going to read these really fast. So John Dalton's atomic theory, let's read through them. We'll just alternate back and forth between you two, and I'll take the last one. So, first one, Chris, what do you got?
Every element is for tiny, invisible, and certain part of the planet.
Alright, is that true today?
Yes.
No.
What?
No.
Okay, no.
Yeah, it's one of those, okay, this model, it worked at the time, but today science discovered, okay, no, it's not quite right. Because atoms, we can break them apart today, but at this time, he just didn't know that. Alright, Ethan, read the next one.
All the atoms of a particular element have the same size, mass, and chemical behavior.
Alright, is that still true for today?
Yes. No.
Nope, not today. We actually know that some atoms are slightly heavier of the same substance than others. We'll talk about reason why and why tomorrow, but I'm running out of time. Quickly, read number 3.
Differences, properties, and elements result from differences between atoms and elements.
Job number 4.
The atoms of an element combine them. They compound combine and then
Did I play by tomorrow?
A chemical reaction is the result of rearrangement and a combination and separation of atoms.
I said I'll read that, I'm sorry. But yes, good job reading it. Okay, just about out of time, so you don't have any homework, but make sure you were studying because Thursday, but keep in mind, you didn't have your quiz today. You might have a practice quiz tomorrow, so if you want the free practice quiz, be ready. But if it's not tomorrow, be sure to be ready for Friday, so you are ready for it. Alright, wait, thinking back, my time is almost up. Thinking back over it, what do you call 2 or more different atoms specifically that are hooked together?
compound.
Good job, what do you call just 2 atoms? Are one hooked together?
Molecules.